The foundation excavation is complete, and the first truck of concrete is on its way. But as you look from the plans to the excavated pit, a chilling thought hits you. Are the walls exactly where they're supposed to be? Is the building perfectly square? If there's even a small error now, it will be magnified up the entire structure, leading to misaligned columns, walls that don't meet, and cladding that won't fit. This is the immense pressure of setting out. It is the foundation of everything we build, both literally and figuratively. In this video, I'm going to walk you through the different methods of setting out, from simple techniques for a garden wall to the advanced technology used for skyscrapers. My goal is to give you the confidence to know that what you're building is exactly what was designed. Before we dive into methods, we have to talk about the golden rule of setting out, the principle of working from the whole to the part. What does this mean? It means you never start by detailing individual columns or walls. You always begin by establishing the main control of the entire site, the primary baseline and benchmark. This is your fundamental reference framework. From this primary control, you establish larger grids, then smaller grids, and finally, you set out the individual points for foundations and columns. This systematic approach prevents the accumulation of small errors. If you set out each column individually from a single point, a tiny angular error on the first one could mean the last column is a meter out of position. By working from a whole site grid down to the details, you contain and minimize any error, ensuring the building fits together as a coherent whole. Let's start with the most basic and historic method, perfect for small structures, boundary walls, or verifying other work, the 3-4-5 method or Pythagorean theorem. This is a method for establishing a perfect right angle without any digital equipment. The principle is based on the Pythagorean triple, 3 superscript 2 plus 4 superscript 2 equals 5 superscript 2. On the ground, you establish your baseline. From a point where you want a 90-degree angle, you measure 3 meters along the baseline and mark it. Then, using 2 tape measures, you swing a 4-meter arc from your original point, a 5-meter arc from the 3-meter mark. The point where these 2 arcs intersect forms a perfect right angle with your baseline. You can scale this up June 8, 10, September 12, 15 for larger layouts. A pro tip from experienced site engineers: always use a steel tape for this, not a cloth one, as steel doesn't stretch and provides the required accuracy. This method is brilliant for its simplicity, but it's limited to small areas and is not suitable for complex or large-scale structures. For the majority of traditional building projects, the coordinate or offline method is the industry standard. This is a 2-person job, typically using a total station. In this method, you have a pre-established grid or control network around your site. The coordinates northing and easting of every critical point corner of the building. Column center lines are known from the architectural drawings. The surveyor sets up the total station over a known control point, backsides to another known point to orient the instrument, and then can stake out any point by inputting its design coordinates. The instrument calculates the angle and distance to that point and guides the surveyor or assistant holding the prism pole to the exact location. This method is incredibly accurate and efficient. You can set out hundreds of points in a day. The key to success here is protecting your control points. They must be located outside the area of construction activity, firmly monument, and regularly checked against each other to ensure they haven't been disturbed. A common and costly mistake is having a bulldozer knock out your primary control point on Monday morning. A variation of the coordinate method used for large, open sites like airports, large industrial plants, or road networks is the grid method. Here, the entire site is overlaid with a master grid, say 50m x 50m or 100m x 100m. The corners of this major grid are established with high precision, often using GPS. The setting out of all structural elements is then done relative to this local grid. For example, a column might be located at grid line A5 with an offset of 10.250m east and 5.500m north. This method breaks a massive, unwieldy site into manageable, coordinated chunks. It allows multiple contractors to work on different parts of the site simultaneously, all using the same master control system. The accuracy of the entire project hinges on the initial precision of this master grid. For circular buildings, curved walls, or complex geometries, the radial method is the most effective approach. In this method, the survey instrument a total station is set up at a known central point, the center of a silo, the focus of a curved wall, etc. Points along the curve are defined by their radius from this center point and an angle from a reference line. The surveyor simply inputs the radius and angle for each point, and the total station directs the prism holder to the correct location. This is far more efficient and accurate than trying to set out a complex curve using a series of coordinates or offsets. A pro tip for setting out curves: the more points you set out, the smoother and more accurate the finished curve will be. Don't try to save time by setting out too few points and eyeballing the curve in between. Finally, we have the modern powerhouse of large-scale site establishment, GNSS surveying global navigation satellite systems, which includes GPS, GLONASS, and Galileo. This method uses receivers that track multiple satellites to determine their precise position on the Earth's surface in real time. For setting out on massive sites like new townships, highways, or dams, this is a game changer. It doesn't require line of sight between points, meaning you can establish control points over vast, rugged terrain quickly. The most common system used in construction is real-time kinematic RTK GPS, which provides centimeter-level accuracy. The site engineer simply walks with a rover receiver, and the on-screen display shows their exact position compared to the design coordinates, telling them exactly where to move to stake out a point. The limitation is that GNSS requires a clear view of the sky and can be less effective near tall buildings or under dense tree cover. No matter which method you use, the process isn't complete without two things: profile boards and independent checks. Profile boards are set up outside the excavation area. They carry string lines that represent the face of a wall or a building line. The strings can be stretched across the excavation to guide the construction of foundations and walls. They also carry marks for reduced levels, allowing you to check excavation and concrete depths. But the most critical step of all is the independent check. Once you have set out your points, a different surveyor, using a different set of control points or a different method, must recheck the critical points. This is your single best defense against a catastrophic error. It might feel like a waste of time, but it is the cheapest insurance policy you will ever buy on a construction project. In conclusion, the method of setting out you choose depends entirely on the scale and complexity of your project. A small garage might only need the 3-4-5 method. A residential building will use the coordinate method with a total station. A massive airport will rely on a GNSS established grid. Your role as the site engineer is to understand the strengths and limitations of each technique. The most successful engineers are those who respect this process, who double-check everything, and who understand that the few hours spent on meticulous setting out can save weeks of rework and millions of dollars. Now I want to hear from you. What is the most challenging setting out situation you've ever faced? Was it a complex curve, a site with terrible access, or a tight urban location? Let me know in the comments below. If this guide to setting out methods has given you more confidence, please give this video a like and subscribe for more content that helps you build your expertise from the ground up.